All right, so I think we're good to go. So welcome to week 2. Any questions up front? So last week we were starting to talk about shell scripting, and we're going to go through that in more detail today. We're going to talk about the next one-day programming assignment. We're going to dig into all things shell script related, and then move on to talking about Git probably tomorrow. So questions before we jump into all of that?
I actually have a question about scripting.
Okay.
So I was trying to write a script to use a cd command, and it wasn't working.
Ah.
So
So scripts run in their own bash environment, their own bash shell. So if inside a script I say change my directory to such and such, that will work inside the script. But once the script exits, I'll find I'm still in the original directory because that CD ran in a different bash shell. It creates basically a whole new bash process, and that's where your directory changed.
okay, that makes sense. Is there any
So
way to get around that?
well, so you can say source space and the name of a file, and it will read the contents of that file and execute it as if you were typing it in your current bash session. And so if in that file that I sourced I did a CD, it would change my current directory in the bash session that I'm actually sitting in. And then when the file exits, I would be in a new directory. But it may be an alias will work well for you, because if I alias something to a big long command that includes a CD, then that CD will get executed by my actual current shell, and that would change my directory.
Okay, thank you.
All right, you're welcome. All right, well, let's see. So let's talk about your next ODP, ODP 402. So ODP 402 is posted on Canvas, and starting with this ODP, the details are going to be in a README file. So let me log into the Linux machine. And if I look at README 402, and I'm using more to look at this file, it's a short file, but in general, if I want to read the contents of a file, I use more instead of cat. More, remember, just shows you one page at a time, and you use a space bar to go from page to page. So, but more or cat, take a look at the contents of this file, and you'll see a short description of it. So for ODP 402, you're writing a bash script, okay, that reads one line of input from the user, typo should be from the user, interprets that as an integer, and prints out 2 times that integer. Okay, and that's all that your ODP does. And it's really important that it does nothing else. It should not put out a prompt. It should not say, please enter an integer. It should not say, welcome to my ODP 402. It should not print out the answer is followed by 2 times the input. Okay, you run it and it does nothing but sit there and wait for input. And then once you type in your input value, it prints out twice that value and it exits. Anything else, you're not going to get 10 out of 10 on your assessment tests. Okay, so it's got to run silently. And I specified bash script here, but originally I just said script. When I say script, that usually means a bash script. Okay, a script is usually human readable. An executable program or a binary program is something that's compiled. So when you write a C program, if I just type in the name of that C program, main.c, I get errors because the CPU can't run a C program until we compile it. And the bash shell doesn't understand what C code is. So a C program we compile into an executable image, something containing ones and zeros, okay, and that's a runnable program. A script is just human readable, and usually it's a bunch of bash commands that'll get executed one after another and might contain loops and so on and so forth. So for 402, you're writing a script, okay, and it's going to read one line of input. and then print out twice the value. And so here's an example of what it should do. So if I call my script goodprog, I run it, it doesn't print anything, it doesn't display anything, it doesn't do anything except wait for me to type in a value like 1, 2, 3, hit enter, it prints out 4, 5, 2, 4, 6, and it exits. Okay, that's all it does. So let's say I try to write my script, right? And there's my attempted ODP 402. Okay. First thing you should do is run this script yourself and make sure it works. Don't assess it until you're pretty sure it works. Using the assess command as kind of your test to see if your code is correct, not a good idea. Okay. Convince yourself that your code is correct, and then assess it just to submit it for a grade. So if I do that, I'll try to run ODP 402, and immediately I see I've got a problem. I did not make it executable. Okay, so change the permission. And now if I run this, it works, right? And I think this is what the ODP is supposed to do, so I'm ready to assess it. Okay, to assess it, type in the name of the file twice. The reason we're doing it twice, normally we use assess with executable binary programs. So we say assess, this is the runnable program, this is the source file. For a script, it's the same thing, the runnable and the source file are the same, so you put that in twice. So assess ODP 402, ODP 402. There's my usual menu. The only command we care about is G, submit for grading. Type that. I get some error messages. I get a 0 out of 10 on all 3 tests. Okay, so I've got 0 out of 30 now. So exit, make some changes, and go from there. Alright, I'll just write a program that outputs a 0. Try assessing that, submit it for grading, still get 0 out of 10. Alright, so now you got to go back and you got to look at the README again, and you got to think very carefully about what it's asking you to do and compare it to the code that you wrote. And in our case, the README will tell you, write a script that waits for an input, multiplies that number you input by 2, and prints that out. So you want to use the read statement, you want to read into a variable, and then you want to use $paren, you know, variable name times 2, and echo that.
Just a question.
Sure.
Does it need to be able to handle anything other than an integer input?
Nope, you can assume it's an integer.
Okay, thank you.
Yep. All right, so I posted a synopsis of bash statements on Canvas, and this is just kind of a rehash of what we've already done last week, but it's all in one place. So this is a 5-page summary of while loops, conditional statements, ifs, doing arithmetic. And again, my disclaimer in here that when you write bash in this class, you have to do it using these exact structures. Okay, you may be able to write a while statement differently from this, and it may work in some cases, and it may work in all cases, and it may be perfectly correct according to the bash police, but if you don't write it in this way, you're not going to get full credit. Okay, this is one of the few times I'm going to be very dogmatic about how you write code. For bash, I want your statements, your whiles, your ifs, your arithmetic to look exactly like this. Okay, so quick rehash, right? A while loop, while, that's a keyword, followed by at least 1 space, followed by 2 square brackets with no spaces in between, followed by at least 1 space, followed by a condition, space, 2 closing brackets, separate line, the keyword do, that's your opening curly bracket, followed by the statements you want executed, indented at least 1 or 2 spaces, followed by on a separate line the keyword done, that's your closing curly bracket. Okay, and so this is, saying I'm doing a while loop. This is the beginning of the body of the loop. This is the end of the body of the loop. The body of the loop goes in between. Indent it so that visually when you look at it you can see this is not just code that's executed sequentially one line after another. This is inside some larger structure, in this case a while loop, in another case maybe an if statement. Alright. So let's talk about conditions. Conditions are about comparing things, right? Basically wanting to know if two things are the same, one thing is bigger than something else, and so on and so forth. Or more generally, checking some, statement which is either true or false. Okay, and there's two kinds of comparisons we need to worry about. The first is just comparing strings. So a string is just a collection of characters. And they might be characters that happen to be digits. That's totally fine. The question is, are we taking this collection of characters and treating it as a number or as just a plain old collection of characters? And if we're just treating it as a sequence of characters, that's what we call a string. And the only way that I'll let you check to see if two strings are the same is to use equal sign, equal sign. Okay, so if I want to know if this string, which is in a variable called x, is the same as the string HELLO, use two equal signs. Okay, put spaces on either side of the equal sign. So if double quote, and put the things you're comparing inside double quotes. So if double quote $x equals hello, that tells me if x is a variable whose value is HELLO. And if you want to know if two strings are not equal, use exclamation mark followed by equal. Exclamation mark is generally a negation. Okay, and that's it. Comparing two strings, either equal or exclamation mark equal. On the other hand, if we want to compare numbers, if this sequence of characters is actually supposed to be an integer, 247, right, and we want to compare it to another integer, typically to know if it's bigger than or less than or something like that, use one of these 6 operations. -EQ, -NE, greater than, greater, equal, less than or equal to, right, which correspond to this. So if I have a number x and I want to know if it's equal to a number y, don't use equal, use -EQ. Okay? Just make that distinction early on when you're writing this code. Am I comparing strings or numbers? Okay? Ignore the fact that everything is basically a string, because my variable x, even if it's the number 23, it's really just a character 2 followed by a character 3. But how am I wanting to do this comparison? As sequences of characters or as numbers? If you're comparing numbers, use one of these 6 comparison operations. And then everything else is the same, right? Don't put quotation marks around your values. So first thing, comparison operation, second thing. Alright, if I want to negate a condition, I can put an exclamation mark in the beginning. I can say, while not I is equal to 10. And if I want to combine these conditions, I can use 2 ampersands for an and, 2 pipes for an or. And, put in your whole bracket condition, way that you want to combine it, and then your next bracket condition, and so on. Alright, if statements, the condition looks exactly the same. If I'm comparing strings, use equal, exclamation mark equal. If I'm comparing numbers, use -EQ, -NE, -GT, and so on. The if statement itself, keyword if, space, bracket, space, condition, space, close bracket twice. Next line, keyword then, that's your opening curly bracket for an if. Next line's the body of your if statement. Final line, the keyword phi, that's if spelled backwards, that's your closing curly bracket. So if, this marks the beginning of the body of the if statement. This is the end of the body. Here's the body itself. Indent it so that it stands out from the rest of your code. If you want to do an if then else, same thing, if condition, Keyword then, here's the body of the if statement. Keyword else, here's the body of the else statement. And then phi to end the whole if. So this is in C, this is a opening curly bracket. This is a closing curly bracket, else opening curly bracket. All right. If my else is actually conditional, I can do an if then else if. So if condition then body of the if statement. Else if is the keyword ELIF, followed by the condition for this next conditional, then body of the second condition. This could be another else if, it could be an else, or it could just be a phi to end the whole if statement. All right, practice those, burn them into your brain, get good with them, get familiar with them, get comfortable with them, okay? This is all you need to know about writing while loops and if statements in Bash. There are a zillion other things that you can know about this. There are a zillion other ways you can do this. But if you know these few pages, you can write while loops, you can write if statements, and do all your coding that you need to do in Bash using just these structures. Okay, so I really, really, really recommend, unless you're already a Bash whiz and you already know how to do this yourself, right, and you're just going to dial it down for this class, unless that's your case, learn to do things this way, right, and just internalize it and stick to it, right? Keep this reference handy, and the first few times you're writing scripts, come back to this and make sure you're doing it this way, and then it'll become a habit, and you won't have to think about it anymore. All right, the other thing on here is arithmetic, and if you want to do arithmetic expressions, yeah, use this structure, $paren, put your expression inside, and then two closing parens. And that will evaluate the stuff inside the parentheses the plain old way that you would expect it to be evaluated, say in C. So you don't need dollar signs in front of variables unless you use a variable like $1, and then you need that. But you can do addition, subtraction, multiplication, division, modulo, arithmetic, etc., etc. All right. Stay away from plus plus and minus minus unless you want to dig into it and maybe deal with a challenge, because they don't always work the way that you expect. The last thing on here is checking for legality of an integer, and this comes up sometimes. We'll talk about it more when it's more topical, but if you read an input from a user and they're supposed to type in a number, how do you know if you've got a number? Well, there's lots of ways you can do it. You can find lots of ways online using regular expressions and sed and all kinds of stuff. This is a pretty straightforward way that mostly works pretty well. And this is basically taking their input, turning it into a number, but then seeing if as a string it's the same as the original input. It's not 100%, but it's about 99 point something percent successful in knowing if the person typed in a valid integer or not. So we don't need that too much right now, but it's on that synopsis sheet anyway. All right, any questions on any of that? How do you get the script to run? How do you get the script to run not on startup? I'm not sure what that question is. So normally when you want to run a script, you just type in the name of the script, enter, right? Change the permission bits to make the execute bit on, so change it to 755 or something. The script won't run unless you do that. So yeah, send me another version of that question if that wasn't what you were asking. Another question, what cases does that not work for comparing the integer? It works for all the cases I've tried, but I'm not going to say it's always going to work. In particular, if you try to do input with a different radix, like if you input 0, 7, that means octal 7, which is a valid number, but I think it will fail this test because this will translate to 7 and this will be 0, 7. So there's some fringy edge cases. but we're not going to worry about it too much. All right, let's see. So that's the ODP. That's the rehash of scripting. Let me make some notes to myself. All right, so let's talk about arguments. So this is a terminology issue, but it's going to be critical in most of what we do and most of what you turn in. You're running a program, right? And sometimes we have a program that we just wanted to do something, and it's always going to do exactly the same thing. But more usually, we run a program, it's going to do something in response to some input. Right? So depending on what we give this program, what information we give it, it will do something different. And there's two basic ways that we can supply information to a program. So feeding information to a program. And there's two ways to do this. One is what I'll call runtime inputs, or maybe user inputs, or maybe just inputs. This is the usual way that programs work, right? You run the program and it says, "Hi, what's your name?" and you type in your name. And it says, "What's your magic number?" and you type in 7, and it does something else, right? So it typically asks you for some value, or maybe it just silently waits for it. But while the program is running, you're giving it information, you're supplying inputs. Okay? And that's kind of our usual modality. So there's a program called BC. It's a calculator program. So I run BC, and it's sitting here waiting for me to type. And I say, 2 times 3, and it says 6. Okay, so it's reading runtime inputs from me. Okay, that's one way to supply information to a program. A second way is to use what we call command line arguments. And this is fundamentally different from runtime inputs. Command line arguments are things that we type in the same line where we're typing the name of the program we want to run. So for example, let's kick out of here. For example, I want to edit a program. I say VI space. I don't hit enter, and VI says, "What program do you want to edit?" And I type in the name of my program and hit enter. That's not what happens. Well, I'm specifying the program I want to run, VI, on the command line. Right here, I also specify my first input to the program, which is the name of the program that I want to edit. And when I say enter, this program starts to run, and it reads this input from the command line. And I never have to say, please edit the program, .c. I'm specifying it right here, and it goes ahead and it starts executing that. That's a command line argument. And once this program is running, it goes ahead and it takes runtime input from me. Right? But the name of the program, that was a command line argument. And if I want to open my program in read-only mode, I put 2 command line arguments. I put a -r and I put .c. Sorry, that was recovery mode. All right, when I compile a program, gcc-o main.c, these things are all command line arguments. Okay, this is saying make my executable program called main and compile the program main.c. if these were runtime inputs, what would happen? I would say GCC enter. It would say, what program do you want to compile? I'd say main.c, enter. It would say, what do you want to call the output file? I'd say main and hit enter, and then it would go ahead and compile. That would be really, really annoying. Okay. Generally, specifying runtime inputs, it's a back and forth process. You're having a conversation with your computer. Sometimes that's what you want. A lot of times it's not. A lot of times you want to specify information to the computer, but you just want to do it while you're also saying, hey, I want you to run the GCC program, or I want you to run VI. So we put those arguments on the same line as GCC. Okay, everybody clear on the difference between these two things? And we'll re-emphasize this, you know, going forward when we have assignments. But make sure you're clear on the difference for these. So ODP 402 is using runtime inputs. Okay, you're going to say ODP 402 enter, and it's going to wait for you to now type in a number while the program is running. You're going to type in 23, hit enter, it's going to print out 46. Tomorrow's ODP 403 that we'll talk about tomorrow will use command line arguments. So you'll say ODP 403 space 23, enter, and it'll print out 46. All right, so let's talk about command line arguments in bash scripts. So in C, there's this fairly confusing system of argc, argv, char star star, argv bracket, argc -1 segfault, right? In bash, it's a whole lot simpler. Okay, in bash we have some predefined variables for us that let us know how many arguments we have and let us get a hold of those arguments. So we're talking about command line arguments in bash scripts. So there's a variable called $number, and $number is always the number of arguments. $1 is the first argument, $2 is the second argument, and so on. All right, so let's play around. So let's play around with command line arguments for a bash script. Well, I want to understand more about $number. What do we mean by number of arguments? I'm going to do the simplest thing possible. I'm just going to write a basically one-line script to show me what $number is. All right, so I'm just going to say $number is, and I'm going to print out the actual value of $number. All right, I'm going to change this to be executable. I'm going to run args, and it's going to say $number is 0. That's telling me I have no command line arguments. And someone says there's typos in README 403. Okay, thank you. I will work on those. So there's no arguments when I just say args. If I say args hello, $number is 1. If I say args hello, this is a test, or a test, $number is 5. Hello, this is a test. 5 arguments. If I say args and I say this is a test 2, but I put it inside double quotes, guess what $number is? It's just plain old 1. This is a single argument. So there's a hint to something really useful. We can embed a bunch of things with spaces in there inside quotation marks and treat it all as a single argument. Whereas without the quotation marks, this is seeing 5 separate arguments. All right, so $number tells us how many arguments we have. $1 will tell us the first argument. And $2 will be the second argument, and so on and so forth. Some more junk code, right? Let's just go ahead and explore this. Args, this is a test 2. Well, is this, 2 is test 2. If I say args hello, $1 is hello, $2 through 5 are just empty strings. Okay, C, this would be a seg fault. Bash, they don't have values, they're just blank. And I know I have one argument because $number was equal to 1. So $1 is meaningful, the other stuff is blank. So here's a weird invocation. Hello, quote, quote, haha. Well, $number is 3. I have 3 arguments. The first one is hello. The third one is haha. The second one is a string containing nothing. It's a string of length 0, which you can see here. $4 is also a string of length 0. But that's a string of length 0 because I didn't have a 4th argument. And I know that because $number is not 4 or bigger, it's 3. All right, so this is what one teacher I knew used to call junk code. Okay, it's code that you're not writing to turn in, you're not writing to put on your portfolio when you go to an interview. It's code you're writing just to explore something, just to play around. And this kind of code is usually pretty small, and it's not well commented, it's not well structured. It's just trying to find out what's going on with some stuff. All right, so here's another example. There's a command called shift. And shift is used to basically take all of your arguments and move them down one spot. So if I say shift, the second argument will now be $1, the third argument will be $2, and so on. So let's just use the shift command. So I'll say shift, and I'll say args, this is a test. Well, now $number is 3, and the first argument is followed by test. And so shift is a way that we can iterate over arguments in a command line list. Right, by moving them down one spot at a time until $number is equal to 0. All right, so somebody brought up the shebang, which I was going to talk about tomorrow, but we can talk about it now. In the beginning of scripts, you usually see this. And pretty soon we're going to want to get in the habit of putting that as the first line of our script. Here's the deal. When I say something like args, right, the reason that this is doing what it's doing is because args contains a bunch of statements. And if I just type in the name of a file, and that file is marked as executable, my shell, which is bash, will start reading these statements and executing them. Okay? Now my current bash is shell. If I do a PS, I can see I've got a process named bash running, which means bash is what is interpreting these. But if I was running a different shell, like the corn shell, for example, the corn shell may not know what to do with this, because the syntax of bash is very different from the syntax of some other shells. So I might write a script that works great for me, and I give it to somebody else, and they're running a different shell, and they try to run the script, and it blows up. And it says syntax error, syntax error. So what you can do is you can put a first line in a script, which is called a shebang. It's a number sign followed by an exclamation mark, followed by the full path to a program. And this program will get executed to interpret the contents of the script. And so if I always want people to run a script using bash, I can put this in the beginning of my program, and the program will run as if it's a bash program. All right, so that's called a shebang, and we'll get in the habit of always putting it in the beginning of our scripts. But like I say, I'd originally planned to talk about it tomorrow, but you got it for free now. And it doesn't appear to change anything for us. And notice that it's a number sign exclamation mark. Number sign is just a comment, right? So technically, comments are ignored by the interpreter, with one exception. If your first line of your script is a number sign followed by an exclamation mark, it takes whatever else comes on that line as being the program you want to run to execute your script. So we make that /bin/bash. And it will look exactly the same as before. Right, but if I put something else in there, like /bin/haha, I'll get a weird argument saying it doesn't have an interpreter named /bin/haha. We'll have a few cool things that we do with that towards the end of the course. All right, so shift basically moves things down one spot. And so we could iterate over our arguments. So we could say, while $number is not equal to 0, do next argument is $1, shift, done. And then we can say all done. All right, so what's going to happen? If there's no arguments on the command line, it's just going to say all done. If we have one argument on the command line, it will print that out, and then it will shift, which will move that first argument, it'll throw it away, and $1 will be missing, and $number will be 0, and our loop should exit. Alright, so I looped 3 times. Each time $1 had the value of the next argument, and then when I was done, I exited my while loop and said all done. Alright, everyone still good so far? All right. There's also a $0. And $0 in this case is just ./args. So $0 is the name of the script that you're currently executing. And that can be useful sometimes. And that's just like argv (0) and C. That was the name of the program we were executing. So sitting here in my bash shell, if I echo $0, it's -bash. That's the program, that's the thing that I'm currently executing. $1 is missing, $number sign is 0. So my program that's running right now is bash, right? Run without any arguments. that's a little weird to think about. All right, questions? All right, let me mention a trick here. So suppose I do something like this. Alright, so I'm running my args, I'm saying hello with a bunch of spaces at the end, I'm saying this with some spaces on either end, and then is fun. And if I look at the output of my script, you know, next arg is hello, next arg is this, well I can see I got some spaces in the beginning of this, and there's is, and there's fun. I don't have any way of knowing from looking at my output though that I have spaces at the end of hello. I don't know if those are there or not. Same thing after this. And a not uncommon situation is you run code and you accidentally have some spaces at the end of some characters and you don't know it. And those spaces are causing your script to misbehave. And you run, you know, you put in some debugging statements, you print out the value of your variables, and they look correct, right? This variable should be hello. Yeah, that's correct. It's only 5 characters. Why is my code looping 10 times? I don't get it, right? So here's something really simple that can save you a lot of time and frustration. Whenever you're looking at the value of, say, a variable, put some delimiters around it. Okay? I'm just printing an angle bracket before and an angle bracket after. But the purpose of this is to let me know if there's trailing spaces or something else that I can't see just by looking at my output in my window. So just by doing that, I can immediately see, hey, I got some extra spaces here. Okay? That's an effortless trick. It takes you, you know, a few extra keystrokes, but again, if you just kind of ingrain that as a habit, it can save you a lot of time, okay, and a lot of frustration. Let's see, question, is there a way to have a script execute in a new shell window or a tab? So scripts do execute in new shells, but to open up another window, that takes some extra work. And that's a little bit outside the realm of Bash, because these windows, the fact that I have a window here, or I can open up another tab and start doing some stuff over here, that has more to do with the underlying operating system, right? Linux in my case, and with something called an X window server. And that there's probably a way to do it from Bash, but it's not a direct way that I know of, depending on your environment. Now, if you use certain programs to connect to a server or to open up a Bash session, there may be sequences of characters you can send that program will interpret as open up a new window. I'm thinking Tilix in particular right now probably has some hooks for that. But I'm going to say for now, probably not an easy way to do that. All right, and also a question, tell me about shift again. So shift basically just moves your command line arguments down one spot. So normally, you know, program, this is a test. So these are the values of $1 through $4. If I say shift, then basically everything gets moved down one spot. So $1 would be is, $2 would be $3 would be test, and $4 would be just an empty string. And every time I call shift, everything moves down one spot. I don't think there's an opposite of shift, because I don't know if those things that shift off get saved anywhere. But you could certainly write a function that would do that would sort of build up an array of values and then shift down but save those values. That would be a cool problem to work on, actually. That might be an optional problem I post at some point. Do an unshift. All right, so tomorrow I want to start talking about Git, and we'll play around with Git and using it to save and track changes that we make to our own code, and give us the ability to roll back and so on and so forth. But we're going to move quickly to talking about GitLab, which is being able to take your Git repository and push it off to the cloud. And so you're going to want to set up an account on GitLab if you don't already have one. And if you like, I suggest go ahead and do that today before tomorrow's class. Go to gitlab.com, and it's GitLab, not GitHub. Go to gitlab.com and set up an account. It's the usual drill. Give them an email address, pick an account name, confirm or validate your email when they send you a note, and you're good to go. They don't spam you, and so on and so forth. And we're going to need to use GitLab for submitting projects in this class. So if you go ahead and set that up at least, right, that gets you most of where you need to be so that we can start going through a full Git and GitLab setup tomorrow, and you can play along while we're doing this. You can also read this if you like to get a heads up. This is just sort of like reasons why you might want to use Git and GitLab in your personal life. We'll play around with the initial setup and so on. The one kind of quirky thing you're going to have to do is set up an SSH key pair, and you can read how to do that in here. If you go through initial GitLab setup, this is all stuff you can do without really understanding anything about Git. Do a key gen, go ahead and grab a copy of your public key and then paste it into GitLab under the key section. So we'll go through this tomorrow, but you can get a heads up on it today. All right, that's all I got for today. I will see you in 2:15, or I will see you tomorrow. Thanks. Bye.